Hey Math Kids, today we're going to talk about right angles in geometric figures, and we're in Chapter 7, Section D, and we will start with example 4. So there's two parts on this example. We're given two different triangles, and we just need to find the unknowns. And so this one is x centimeters. It's given that it's isosceles, 67 degrees, 10 centimeters. So just to be clear, like even though it's not given, we know these things right here. Now, a property of isosceles triangles, well, is that if we drop this down, oh my goodness, this is not good. I don't know what's going on. Okay, if we drop down that, once again, your book has a better picture of that, but it creates a perpendicular bisector right here. So it's going to cut this perfectly in half, and so that's going to be 5 centimeters and 5 centimeters, cutting that 10 in half perfectly. It also cuts these angles in half up here. We're not going to end up using that, but now that we have a right triangle, we can go to SOHCAHTOA to help us out. And the stuff that we're interested in / the stuff that we know, so if we think of this as our theta, we have the adjacent and the hypotenuse. So adjacent hypotenuse is going to be cosine. So I'm going to say cosine of 67 equals the adjacent, which is 5, over the hypotenuse, which is x. Okay? We want to solve for x, so I'm going to multiply both sides by x, and we get x cosine 67 equals 5, because those x's cancel. And then we want to get x by itself, so we will divide both sides by cosine 67. And that leaves us with x equals 5 over cosine 67. We plug that into a calculator. I'll do a quick review on that. So we have our calculator. We want to hit mode. Make sure we're in degrees. So go down to degrees, hit enter, get out of here, and just say cosine 67. Whoops. Sorry, it's 5 divided by cosine 67. And we get 12.79, which if we round that is 12.8. And that's centimeters. Okay, I'm going to actually go down here for this next one. So we have another triangle. I'm going to draw it a little bit closer to how the book had it. So it's like this. Once again, it's an isosceles triangle. This time these two are the same. We have 8.3 meters, which means this is also 8.3 meters. We have an unknown angle that they're calling alpha, and then this opposite side to that angle is 5.2 meters. Okay? Now, we've only learned about right angle trigonometry, so once again, we're going to drop this down, create a right angle right there, and we cut this in half. So we get 2.6, I believe, right? 2.6 for each of these sides. 2.6, 2.6. And that cuts that angle in half as well. So we're going to call this angle alpha over 2. Sorry, alpha over 2. And so now we'll work with that. So if this is our theta. We have the opposite side, and we have the hypotenuse. So if we look at SOHCAHTOA, that's a sine with the opposite and the hypotenuse. So we will say sine of alpha over 2 equals the opposite, which is 2.6, over the hypotenuse, which is 8.3. Okay? So the algebra for this, we just do an inverse sine. Those cancel. We have alpha over 2 equals the inverse sine of 2.6 over 8.3. And then we want just alpha, not alpha over 2. So we multiply both sides by 2. And so we have 2 inverse sine of 2.6 over 8.3. Pull up our calculator. Move it out of the way. 2 second sine, which brings up our inverse sine. And then parentheses. Oh, it already started one for us. So 2.6 divided by 8.3. And we hit enter on that. And our degree measure would be 36.5. And that's our alpha, the value of alpha. Okay, we're going to move on to example 5. It says a rhombus has diagonals of length 10. So I'm going to draw a rhombus. Sorry, my drawings are really bad. Okay, whatever. That's good enough. And we have diagonals that are... I don't know why I'm having such a hard time today. Something's going on. Okay. There we go. There we go. So each of these diagonals says is 10 centimeters. So blue equals 10 centimeters. Or, sorry, one of them's 10. I didn't read that far enough. So let's say one of them's 10, and orange is 6 centimeters. Find the smaller angle of the rhombus. Okay. So the 10, it's not super obvious in this picture, but since the 10 is kind of stretching it more, the smaller angle is going to be, and they want it of the entire rhombus, so we're actually like looking at this angle is what they want. Okay. So I'm going to do it pretty similar to the book. So we're going to call each of these theta. So the green one is going to be our final answer, which will be 2 theta. And so that's what we're looking for. But since we're going to be dealing with these triangles, yeah. So the rhombus, the diagonals create a perpendicular intersection, and they also bisect each other. And so we know that this piece is 3 centimeters, and we know that this piece is 5 centimeters, and we want to know this angle. So it really just becomes this problem, 3, 5, theta, like that. And so if we're looking at SOHCAHTOA, from this angle we have the opposite and the adjacent, so that's tangent. So we can say tangent theta equals the opposite, which is 3, over the adjacent, which is 5. And then we just go through a little bit of algebra. We do the inverse tangent of both sides. Those cancel. So theta is equal to the inverse tangent of 3/5. So we go to our calculator, and we say second tangent, 3 divided by 5. And that is 30.964. But remember, our final answer was supposed to be the entire angle here, which is 2 of our thetas, which we have written right here. And so we just need to multiply that number by 2. So we times our answer by 2, and we get 61.9 degrees. Okay, we're going to move on to example 6. Okay, it just wants us to find x for this figure. These are marked as being parallel. That's what those little arrows mean. Then we have x centimeters right here, 48 degrees right here, 65 degrees right here, and 10 centimeters right there. Okay, so since those lines are parallel, we can drop these down and make them perpendicular. Okay, so essentially what we want to do is use the information that we have over here to find this. This will be the same height, so both the yellow lines are the same, and then we'll use that to find x. So let's take it one piece at a time. We're looking for this, and I'll call this A. So we have the opposite and the hypotenuse, so that's sine. So sine 65 equals the opposite over hypotenuse. We multiply both sides by 10. 10 sine 65 equals A. Get our calculator. We say 10 sine 65, and we get 9.063. Okay, so that's 9.063, and that's 9.063 for this line, and then this one's also the same. So now we're going to look at this triangle. So it becomes 9.063, 48, and x. Once again, we have opposite over hypotenuse, so that's sine again. So sine 48 equals opposite over hypotenuse. And then we just have to solve that. So we multiply both sides by x. We get x sine 48 equals 9.063. Divide by sine 48. We're left with x equals 9.063 over sine 48. Now, because we want to get an exact answer, this and this are the same thing. So when I type it into my calculator, I'm actually going to type in this except for this, or instead of this. So this divided by this. So let's open up the calculator. I'll clear the screen to make this clear. So we're going to say 10 sine 65 divided by sine 48, and we end up with 12.2. So our x right here is 12.2 centimeters. Okay, now we have one more example. It's example 7.